This video is going to focus on solving linear equations. It can be found on page 2 in your notes. So solving linear equations, this is a revision topic. We have done this numerous times in the past. So the method that we're going to be looking at using, we'll look at two ways. One will be the CAS calculator, and I'll go through that at the end of this. But the first way is inverse operations. Inverse operations are our opposite operations. So for instance, if I've got a positive, or not a positive, sorry, a plus, then the opposite of that is minus. A minus, opposite is plus, times, opposite divide, divide, opposite times. Those are our main four, but at this level we also need to look at our square roots, and the opposite of a square root is to square it. Vice versa, so a square, the opposite is to square root it. And I'm not going to write them down, but you've also got higher powers, so cubed root and cubed, for instance, 10th root and to the power of 10. Those are all very valid inverse operations. So I'm going to leave it at that for our inverse operations at this point anyway. So now the order that we approach solving is given by our order of operations BIDMAS, but we do it backwards. So BIDMAS backwards. We look for a subtraction, we look for an addition, a multiplication, a division, any indices, and then our brackets. So that's the order that we undo our processes. The general name of this solving technique is called the balance method. So the method we're using is the balance method. Now we're going to go through 6 examples and then we'll look at the CAS method. Alright, example 1. So there's 4 examples with numbers and 2 examples that are with pronumerals, our letters. So first step is we have a divide by 5. Opposite of dividing by 5 is to times by 5, which will leave us with 3x equal to 10. Divide by -3. Notice that that is dividing by -3, not plussing 3. The reason for this is that this here is a -3. My advice is that somewhere you write yourself a note about that. For instance, note. -3x is -3 times x undo the multiplication by dividing -3. Alright, this process will always be the same if you've got something like this, a negative out the front, because it's a negative, not a minus. That quick note there, just chuck into a box. Alrighty, so back to doing this question. Dividing by that -3 is going to leave me with 10 divided by 3. We have a negative. The negative is divided with the 3. However, notation would have that on the bottom of the top of a fraction. So I'm going to write that as -10/3 and then box my answer, because whoever's marking your work needs to be able to find that answer first up. That's the first thing they should be able to see. And moving on. 1b. Our first step for this particular question is going to be to get rid of this 14. In front of this 14 that's invisible but it is there is a plus. Okay, there's always a plus in front of a value with nothing in front of it. So to undo a plus 14, we are going to minus 14. This leaves us with minus 3, negative 3, I apologise, and negative 6. Next step is to divide by negative 3, which leaves us with y equal to 2. Now it's positive 2 because a negative divided by a negative will give me a positive. That's my end answer. Box it, and I'm done. Alright, we have a few options here, in fact 2 options. We could divide by 2 to get rid of this, is option number 1. Now if I go through and do this, then I'm going to have everything on this side divided by 2 as well. 7 divided by 2 does not go evenly. It'll leave us with a fraction or a decimal, neither of which we kind of want if we can avoid it. So instead I'm going to take my second option, which is to expand this. So when I expand it, I get 2x plus 8, which is equal to 7x plus 2. From here on in, it's just collecting like terms and solving like normal. I'm going to move the 2x across, so minus 2x from both sides. I'm choosing to move that and not the 7 because I don't actually want to have a negative x. It won't affect my end answer, it's just neater without it. So 8 is equal to 5x plus 2 minus the 5x from both sides. I take that back, sorry, don't minus the 5x. Minus the 2, which leaves us with 6 equal to 5x. I'm going to do 2 moves in the next step. I'm going to divide by 5, but when I write it, I'm going to rearrange it. You should always have your pronumeral or what you're solving for on the left-hand side. You wouldn't be marked down for it, but notation says that that's the proper way to write it. And then box it, and we're done. Moving up to the top. Undo. Alrighty. Our first step here, we could expand again. However, if we multiply by 4, we won't have any decimals and we're going to get rid of that fraction. Where possible, get rid of fractions, get rid of decimals, anything like that we don't want. So we're going to be left with x minus 10 equals to 24. The brackets are gone because they're no longer needed. Plussing 10 to both sides gives me x equal to 34. Box my answer. And that is done. Next question. Part E and Part F don't use numbers, we're just using pronumerals. We're still aiming to solve for x, however we no longer have numbers, but it works the same way. So I want to get rid of the a. My first step is going to divide by a. In fact, my only step is going to be to divide by a, which leaves me with x equal to b divided by a, which I box. Next one, same deal. I'm solving for x, which means first thing I get rid of is the b, which leaves me with ax equal to cx minus b. I've just noticed that I've actually got x on both sides of the equation, so my first move was perhaps not the best move that I could have made. Will I keep it? No, I'm going to get rid of this. Now, you could continue with what I had there. It's just really there's an extra step that I didn't need to do. Instead, I'm going to minus ax. So I'm actually looking to get my x's onto the same side of the equation to start off with. This leaves me with b equals cx minus ax. Now, the next step is not a part of BIDMAS, it's just recognizing a situation that I'm in. I have C and A, but because they're pronumerals, I cannot subtract them from each other to get, let's just throw out a letter D, okay? That's not possible. What I do notice, however, is that what I have here is X and X in both of these two terms. Once I recognize that fact, what I can actually do is to factorize it. By factorize, what I'm referring to is to find the common factor. So the thing that's in common between CX and AX is the X. And when I divide through by X, CX divided by X is C, AX or negative AX divided by X is negative A. So I've now got X bracket C minus A. We can actually divide by that entire bracket, C minus A. Notice I put a bracket around that C minus A. If I hadn't, I'd be dividing by C and then minusing A, which is a totally different thing. So you need to actually have that written out with a bracket. Rearranging my formula, so I've got X on the left-hand side of the equation. B is my numerator, and my denominator is C minus A. Box my solution, and that's now done. So that's solving by hand. We're actually going to have a look now at doing this on our CAS calculators. Alrighty, so on your CAS calculator, we are going to use the solve function. You can access this multiple different ways. So for instance, you can type in using your keyboard down here. You can type in solve. I'm not going to use that method, but it's perfectly reasonable to use. Instead, I'm going to use my menu. So I'm going to go menu, algebra, solve. So menu 3, 1. And inside this, you need to have an equation, i.e. you need something with equals in it. If you don't, solve won't work. And you need to identify what you want to solve for. So for instance, if I've got AB plus C is equal to D, comma, as in comma by what I want to solve for, and I want to solve for B. Now here's an issue. When I press this, it's not going to work. The calculator will not recognize the difference between A and B. It sees it as one unit because I've written it as one unit. So solving for B, if I press enter to this, isn't going to work. Alright, it hasn't given me B equals to something. If I press up twice, press enter. So I'm just copying that line of calculation back down. And I'm going to go across, and between the A and B, we have an implied multiplication. The calculator needs that explicit. So A times B, and press enter, and we get a solution. Now this may not be exactly what we got by hand. In fact, I believe it's not for the similar question that we had. The only difference is negative, so you might have D minus C instead. Okay, but it's the same, just rearranged very slightly different. Solve will work for anything, so you can use solve for numbers. 2x plus 5 equals 10 if I'm solving for x, and I can press enter. Now notice that it automatically put in this multiplication. It will between a number and a letter, but not between two letters. So it's implied, or it recognizes a multiplication between a number and a letter. So that there is fine. Solving it, it gives me a solution of 5 on 2. So this is just, solve is just a way to calculate algebraically a solution to an equation, given certain pieces of information. Be careful that you're not required to make working or to create or put down working to successfully complete a question. that's all for this topic. Next topic, we will be looking at constructing linear equations from worded descriptions.